Hi everyone, in this video I will be introducing a new data structure, linked list. So this will be the first video of the linked list series. Here we'll see what is linked list, what are the applications of linked list, how we can represent it, and what are the different types of linked list. So far we have discussed trees and graphs in my previous videos. So both of these are non-linear data structure. In this video, we will be discussing about linked list. So linked list is a type of linear data structure. So by linear data structure, we mean that the arrangement of data in the linked list follows a linear trend. So the data elements are arranged linearly such that the element is directly linked to its previous and the next elements. So it supports a single level storage of data. So linked list is a linear data structure which consists of nodes where each node contains a data field and a link to the next node in the list. Let's see an example. So this is a linked list and this is a node of a linked list. So this linked list here has 4 nodes. Each node of the linked list contains a data field. So this is the data field and this is the link field, or we can call it as a next pointer, which is pointing to the next node of the linked list. So let's say if the address of this node is 100 and address of this node is 200, address of D is 300. So the first node will contain a pointer which points to the address 100. The second node will contain a pointer pointing to the address 200, and the node P will contain a pointer which is pointing to the address 300, and the last node will point to a null address. So since these can be represented linearly and there is only single level, so that is why these are known as linear data structure. The first node of the linked list is known as head, and the last node, that is known as tail. So the data field can be of any data type. So here I have used characters, but it can be integer or a complex data type. So data type doesn't matter. It's just that each node should have a data field and a link to the next node in the list. So we already know about arrays. So arrays are also linear data structure. So if we have arrays, why do we need linked list? So both linked list and arrays are linear data structure. So if we have arrays, why do we need linked list? So there are some advantages of linked list over arrays. Let's see what are those. So linked list has dynamic size. So when you declare an array, let's say you declare an array of characters. So the form of representation is you need to provide some size of the array. Let's say you create an array of size 10, but it may be the case in future you realize that the array size needs to be 20. But for array, the size is static. So it is provided at the time of creating the array. But linked list is dynamic. So at any point in time, if we have a linked list of let's say 2 nodes, we can always add or delete any number of nodes. So the size is not fixed, it is dynamic. So it can be changed as and when required. So that is a big advantage that we have in case of linked list. So as per the requirement, we can increase the size dynamically. Second is insertion and deletion in linked list is very efficient. Let's say there is a linked list of 4 elements and you have to delete a node which is B. So if you have to delete this node, in linked list it is quite easy. We just point A to C. So we'll just have to change the pointers. So the pointer from A which was pointing to B will now point to C. And then we can delete this node. But in case of array, let's say the array was this. Now if we have to delete the element B, what we need to do is we need to shift all the elements one step before. So B will be deleted, but C and D will need it to be shifted back. So if the array size is very large, then this operation is very inefficient. But in case of linked list, we just have to change the pointer to the next node. So the insertion and deletion in the linked list is very efficient. So similarly in insertion, you now have to insert B here in ACD. You again have to shift the elements C and D one step after. But in linked list, we can just change the pointers and insert a node at any place. So whenever we require that insertion deletion should be very fast and efficient, or we do not know the size beforehand, then in those cases linked list is very advantageous. But whenever there are some advantages, there are some disadvantages also. Let's see what are the disadvantages of using linked list. So one disadvantage is related to the extra space consumption in which we are storing the pointer to the next node. So for each node of the linked list, it contains a pointer to the next node. So this pointer is basically consuming some extra space. So it can be of 4 bytes depending on the language that you use. So some extra space is used for each node of the linked list, but in case of array, we do not require this extra space. Second is random access is not allowed in linked list. So let's say you're given an array and you have to find out what is the third element of the array. So in array it is very easy. So if this is the array, we can simply do array of 2. So this will point us to the third element. So because this is 0, this is 1, this is 2, this is 3 and this is 4. So third element of the array is C. So in array we can directly access any index. So random access is allowed in array. But in case of linked list, we only have a pointer to the head of the linked list. So this will be something like this. So if we now want to access the third element, we have to start from head. So we'll check this is the first element, this is the second element, this is the third element. So we cannot access any element of the linked list randomly. So that is why there are some popular algorithms like binary search, which uses the random access property of the array. So these are not efficient when applicable for linked list, because in binary search and all such algorithms we need to go to the midpoint, but in linked list we cannot find the midpoint directly with the index. So we need to start from the starting of the linked list. So that is why such algorithms are not efficient, because random access is not allowed in the linked list. So in linked list we need to do sequential access. And third is arrays have better cache locality than linked list, because array elements are stored contiguously. So if you create an array of size 10, all the 10 elements are stored contiguously. But in case of linked list, the elements need not be stored contiguously because we have a pointer to the next node. So what the operating system can do is, when it's loading an array in the memory, it can load a large chunk of memory of the array so that to have better performance. But in linked list, since these elements are not contiguous, so the cache locality is less efficient than an array. So depending on the use case of the problem that you're trying to solve, we need to choose the proper data structure. Now let's see what are the different types of linked list. So there are 3 types of linked list. One is the singly linked list. So this is the simple form of linked list that we have seen. So each node will have a data field and a next pointer which is pointing to the next node in the linked list. And the last node will point to null. So this is known as singly linked list because it has a single pointer which is pointing to the next node. Second type of linked list is doubly linked list. So in doubly linked list, each node comprises of a data field, a next pointer and a previous pointer. So next pointer is pointing to the next node of the linked list and previous pointer is pointing to the previous node of the linked list. So this is advantageous because in some scenarios you might also need to go back in the linked list. Let's say you have a pointer to this node. Now if you need to go back to the previous node, you can directly go back to the previous node by this previous pointer. In case of a singly linked list, you cannot go back. So in singly linked list, you just have a pointer which is pointing to the next node. But in doubly linked list, you can go back also. So each node is pointing to the next one also and the previous one also. So the head node of the doubly linked list will have a previous pointer which is pointing to null, because this is the first node of the linked list. Since this is the first node, there is no previous node before this, so the previous of the first node is pointing to null, and the next pointer of the last node is also pointing to null because there is no node after this. So this type of linked list is known as doubly linked list. The third type of linked list is circular linked list. So this circular linked list can be both singly or doubly. So the only difference in the circular linked list is that we will have a pointer from the last node to the first node. So this is singly circular linked list. Singly because we have only one pointer, and circular because the last node is pointing to the first node. So this is the head node and this is the tail node. So the next pointer of the tail node is pointing to the head. So this is singly circular linked list. And then we have doubly circular linked list. So this is similar to doubly linked list, but just that the next pointer of the tail is pointing to head and the previous pointer of the head is pointing to tail. So instead of pointing to null, the head is pointing to tail and the tail is pointing to head. And each node has two pointers, so that is why it is doubly. And because it is forming a circle, so that is why these are circular linked list. Now let's understand how we can represent a linked list. So to represent a singly linked list, we can use a structure which has a data member. So this is basically the data field, and this is the pointer to the next node. Because here I'm using a character value, so I've used character data type. So these two fields comprise a node of the linked list. And for a doubly linked list, we have a data member, we have a next pointer, and we have a previous pointer. So a node of the doubly linked list will have data member and a next pointer and a previous pointer. So these both are pointers. And for a circular linked list, the representation is the same. It's just that the tail will point to the head. So that is the implementation part, but the representation of the node will be the same. Now let's understand what are the applications of linked list. So linked list can be used to implement other data structures like stacks, queues, graphs. So in graphs, we saw that adjacency list representation uses linked list. Similarly, in hash tables, when we have some collision, if we have multiple elements which are falling in the same bucket, then a linked list is used to add all such elements in the same bucket. Other application is if we have to store huge numbers. So let's say we have a number of length 100. So a number of length 100 is quite big to be fitted in any of the standard data types like int, long or long. So such a huge number cannot fit into any of these data types. How these are represented as, we can create a linked list of each digit. So let's say if the number is something like this, then we can have a linked list which is pointing to all these numbers. So each node will be a digit and a pointer will be pointing to the next digit. So if we have to do some arithmetic operations like addition, multiplication, subtraction on such huge numbers, we make use of the linked list. Another application which we have of linked lists, so in browser we have such functionalities like we can go back. So in the top of the menu bar we have some buttons where we can go back or we can go next. So that is analogous to the previous or the next pointer that we have in doubly linked list. So the cache basically implements a form of a linked list of URLs. So when you click on previous or the next, depending on that, it will pick the URL and redirect the browser to that. Similarly, in image editors or text editors, we have the undo redo functionality. So it can be thought of as linked list of state. So when we are undoing an operation, it will change the state of the editor to the previous state. and if we redo it, it will change it to some other state. So all these states can be represented in the form of a linked list, and depending on the user operation, the state can be changed. So these are just few of the applications of linked list. So it is quite commonly used and it is very frequently asked in interviews. In the next video, we'll see how we can create a linked list, how we can search an element and insert delete nodes in a linked list. So that was all for this video. If you like my content, please do like, share and subscribe to my channel. It really motivates me to make more such content. And until next time, this is Sandeep Thapar signing off.